We have 8-3 today. We'll do we're doing some proofs. We're dedicating a day to proofs tomorrow for similarity. Remember, in case you forgot, before winter break, we had some similarity conversations. Similarity ratios. Are these two triangles similar? And our only option at the time was AA similarity, where two of the angles in one triangle were congruent to two the angles in the other triangle, and the angles are congruent, which meant the sides were proportional. All right. So we'll talk about proofs for that once we finish learning all the similarity statements from today. And we'll start 8-4 on Friday. We'll finish 8-4 on Monday. Probably a review, then a quiz mid next week. All right, 8-1 through 8-4. So we checked the homework. Any questions from the homework? Are we okay with writing the similarity statement, getting the order of the letters correct? Okay. Checking for similarity. Why wasn't number 2 similar? They both had a 90. Yeah, and you probably should check this other angle, right? If this is 40, this one's 50. So this one would need a 40 and a 50, and it doesn't. It's a 55, so not similar. That's the kind of logic there. All right. Everybody have a chance to check the answers. Any questions on any of the problems? All right. So today's lesson is called Proving Triangle Similarity by, now we have SSS and SAS. Now we have to kind of separate our minds. SSS and SAS similarity is different-ish than SSS and SAS congruence, okay? We're not going to have the triangles congruent. They're not identical, but they are going to be similar. They're going to be proportional sides, congruent angles, if we see SSS and SAS. Now, what do those mean? Well, our first one, SSS, similarity. It's not going to say if 3 sides in one triangle are congruent to 3 sides in another triangle. It's going to say if 3 sides in one triangle are similar. And what's that word? The sides are proportional, right? That's going to be the key. If the corresponding side lengths are proportional, then the triangles are similar. And all 3 sets of sides have to be proportional. That's where the SSS comes from. Side similarity. Yes, Emma.
When we're writing this on a proof, so do we put SSS similarity to like differentiate them?
Yeah. Yep. And you can abbreviate it. Or you could even put similar by SSS. You know what I'm saying? Like, that would be fine too. Very good. All right, let's practice that. So we have a pair of triangles for A. Well, let's read the directions. Is either triangle DEF or triangle GHJ similar to ABC? So ABC here is our, like, it's the one that's not budging. Okay, we're dealing with ABC right here. It has sides of 8, 12, and 16. We have to decide are DEF or GHJ similar to ABC? All right. Now, some of these are kind of twisted and turned, so let's match up the corresponding sides. What goes with AB in DEF? Well, AB goes with DE. Do you guys see that? So when we go to list, I kind of gave you guys a little help here. When we go to list the shortest sides, in ABC, it's AB, and AB is 8. In DEF, it's DE, and DE is 6. And in GHJ, what's the shortest side? What's the corresponding side? GH. Good. So notice, if you kind of look at how they're lined up, they're kind of twisted or turned or reflected or whatever. So to kind of keep it straight that way. So it's GH and GH. GH is 8. I think we'd have made this file. We're kind of doing it a little differently. I think part A was going to be comparing ABC to like DEF, and then part B was going to be comparing ABC to the other one. Are you guys okay if we just list the shortest sides here, and then does yours have a part B also? Mm-hmm. Okay, so we can kind of do it either way. All right, so let's do that ratio just for the heck of it. What's the ratio from AB to DE? AB to DE. That ratio is 8/6, which reduces into 4/3. This is not the scale factor. Okay? Let's practice that. It's been a while. What is the scale factor to go from this bigger triangle of ABC down to the smaller triangle of DEF? It's not 4/3. That would make it bigger. It's 3/4. You guys all understand that? K is the scale factor. K would be 3/4. Right now we're just comparing them. Okay? All right. How about the middle sides? Well, let's do AB while we're at it. Let's do AB to GH. AB, the shortest side is 8. GH, 8. The ratio is 1. So I guess we'll call this part B, AB. We've already listed out the side length, so AB to GH was 1. Here, AB to DE was 4/3. So if you're separating these, part A, we're seeing if ABC is similar to triangle DEF. Part B, we're seeing if it's similar to triangle GHJ. All right, next set of sides. What is the middle side length of ABC? 12. And BC goes with what in this triangle? EF. And what does it go with in triangle GHJ? HJ, I believe, right? HJ. All right. Well, in the middle sides, in BC, we have this one. We have BC over, we're doing EF. That ratio is 12/9, which reduces into 4/3. Okay, well, the shortest sides had a ratio of 4/3. The middle sides have a ratio of 4/3. We're good so far. Good so far between ABC and DEF. Okay, let's stick with it. We'll do the middle sides for ABC to GHJ. So BC over, what's the corresponding side to BC in the GHJ triangle? HJ, which was 10. So we have BC in the original triangle is 12. HJ is 10. What's that ratio? 6/5. Good. 6/5. And I could actually stop that part of the problem right now and say that triangle ABC is to GHJ not similar. The ratio of their smallest sides was 1. The ratio of their middle sides was 6/5. The ratios would need to all be the same between small to small, medium to medium, big to big. Whether it's 2 to 1, 3 to 2, whatever it is, they have to stay the same between all three sides. Does that make sense? That is SSS similarity. Quick refresher. The corresponding side lengths of two triangles are proportional. Okay? So let's finish this one off and see if it satisfies SSS. The third pair of sides have to be the same proportion. So if this is going to work out, what do the longest sides ratio have to be? 4/3. Let's see. AC goes with what in the medium triangle, or this middle triangle here? Yeah, good. 12. So AC over DF is 16 to 12, which reduces into 4/3. And right there, I can say confidently, triangle ABC is similar to triangle DEF. Triangle ABC similar to triangle DEF by SSS similarity. Just for the heck of it, let's see on the last triangle what the ratio would have been. We know it's not going to work out. It'd be AC goes with GJ. AC over GJ. It'd be 16 to 16, which is 1. Ooh, it was close, wasn't it? What if they were all a ratio of 1? What if the middle sides weren't 6/5? What if they were 1 to 1? Would we say similar? Would we say congruent? Who votes similar? Who votes congruent? Who votes both? If they're congruent, isn't their scale factor 1? Aren't all congruent triangles also similar? Are their sides going to be proportional? It's just going to be boring. Their proportion is 1, right? So if the question asked, are they similar, and the scale factor is 1, we'd say, yeah, they're similar, but they're also congruent. This one failed because the middle sides were not proportional with the same ratio as the other two pairs. All three pairs have to have the same ratio, 4/3, 4/3, 4/3, or 1, 1, and 1. Does this make sense? Okay, probably over-explained that. All right. There is no SSSS similarity theorem for quadrilaterals. You got 30 seconds to talk to your table partners and explain why not.
Because they live in the roadie.
All right, give you guys a little bit of a hint, a little bit of direction to discuss. What shape is this? How do you know?
Because it's equal to a degree.
All right, what are the four sides being congruent and make it? Or back up. I want to try to trick you now so you don't get tricked on a quiz. Okay. What shape is it right now? It's a rhombus. It's a rhombus. Okay. Rectangle, and therefore a square. I agree. I agree with the square now. Okay. A rhombus with one right angle forces all the other angles to be right. Because isn't this a parallelogram because it was a rhombus? Parallelogram, rhombus. Well, if it was a parallelogram, then aren't opposite angles congruent and consecutive angles supplementary? Now it has to have all four right. If it had one right and it was a parallelogram, they're all right. Tally.
Did you take the quiz we took last week?
Yes, and I'm going to try to pass those back today.
I just want to make sure because I couldn't remember.
Yep. I was telling someone else. I got them graded, and I went home on Thursday, and one thing I forgot was my grade book to enter those in. So I'll try to enter them in today before I leave, and then if you choose to use your retake for the 9 weeks, then I'll have to check our syllabus to see how many days you guys need to. You have to correct it and then show it to me, and then get the retake if you've done all your homework for the sections. So do you guys understand? Just because the side lengths are congruent does not mean they are. They might be proportional, but they're not the same shape. When I say shape, I mean dilation, just scale factors of each other. Do you agree these are not? Yes? Okay. So even though the side lengths might be proportional in quadrilaterals, it does not mean the angles are congruent. All right. How can SSS similarity congruence, or how can we use SSS similarity congruence to solve the following? All right, find the value of x that makes these triangles similar. Well, AB would need to go with DE. Okay, so these are lined up how we would like them to be lined up. They're not twisted, they're not reflected, they're lined up perfectly. So what is a ratio we can set up? 4/12. 4/12 equals, well, we want to solve for x. So x minus 1 over, what do you think? What's the corresponding side? 18. Let's see if that will give us the correct setup to find x. All right. Cross multiply or not cross multiply? You can. You don't. You can, but whenever x is in the numerator, you can get away with solving by just multiplying by 18 on both sides. Okay. Again, I know that this is uncomfortable for some of you guys, but I want to stretch you guys to think like a little bit more mathematically mature students. All right. Don't just do a habit because you've always done it that way. Look to find the most efficient process. Again, that's one of my jobs, is to prepare you to be like whatever you want to be, whether it's engineers or accountants or attorneys or, I don't know, construction worker. I don't know what you're going to be doing, but you need to be able to think critically and problem solve. You've always been told to do this, haven't you? I'm going to write it down. Don't write it down yet, okay? You would get 4 times 18, which is what, 72? Double checking, 40 and 32. Yeah, 72. And then you would do 12 times x minus 1. Do you agree? But what about multiplying by 18 on both sides? Wouldn't that cancel here? And wouldn't I do that over here? What would I get if I do the black process? What's 18 times 4? 72 over 12. You can use calculators. 6. What's on the right side? X minus 1. Are they both correct? The black is 1 step shorter. We talked about this last week. Why would you look up here for 1 second? You can cross multiply and you'll get the right answer. But do you agree by multiplying this side by 12, you're introducing another number to the right side that is going to need to be divided by later on anyway? You guys would probably do this, wouldn't you? Yes? You don't have to. Isn't 12 being multiplied to this whole thing? And you want to get x by itself. Move the 12 over. How do you move the 12 over if it's being multiplied? Divide. So we've been taught these processes, which were fine, but like you don't, if it's making that side more complicated, you don't have to always do it one way. All right. Do you understand what I'm saying? Tell me.
Will we get points off?
No, I'm not going to count points off, but it's like teaching someone to make a peanut butter and jelly sandwich, and they're like, and you say, okay, put some peanut butter on the bread, and they're like, well, shouldn't I open the jar of peanut butter first? You're like, yeah, and then you say, put some jelly on the bread. Shouldn't I pick up the knife first? Like, you give directions very, very specifically when you're first teaching someone to do it, but like after you do it for a while, you're like, oh, wasn't that it? Like, do I really need to say that? Like, can't I say it in shorter steps? Can I just say put some peanut butter on the bread? Right? Do you know what I'm saying? I'm not going to count points off, but x equals 7. All right. Now, watch up here. What's the scale factor to go from small to big? 4 to 12 was a scale factor of times 3. Yes, 3. What's this? If this is 8, what should this side be? 24. Everybody agree? Let's plug in 7. What's 7 plus 1? 8 times 3? 24. It works. Okay. So x is 7 is my answer. If they asked you to find the side lengths, you would plug 7 in, and you'd get 6, and you get bless you. No, I mean 24. Now, things to be careful of. If you choose to cross multiply, don't forget to put parentheses around here and distribute, or like I said, you can divide by 12. Again, I'm not trying to confuse you. We're kind of getting ready for Algebra 2 next year, where this stuff, you just need to be very proficient with your number sense and your operations on this. All right. Let's see how much more we have left. Yeah, let's go ahead and do this one. Find the value of x that makes these similar. Go ahead and try to set it up on your own. Hey, everybody. Did you get x equals 6?
Yeah.
Check your work. Did you get x equals 6? If not, ask me, because you need to be good with this algebra. Okay. You okay with that? If you did it this way, now this way, if your x is in the denominator, you do have to cross multiply. You have to cross multiply both parts. One is there, the other one to get x out of the denominator and write it like this. 9 times x plus 2 equals 72. Can I distribute the 9 to the x end of the 2? Do I have to? No. Couldn't I divide by 9 to simplify the left-hand side? Okay. So x plus 2 is 8. X is 6 either way. Are you guys okay with that? Awesome. All right, moving on. Next. Last topic for today. We still have a couple more problems, but last topic is SAS similarity. Can anyone take a guess at what SAS similarity is going to say? Two sides and the angle, I agree, but what about the sides? What about the angle? The angle between the included angle, remember that word? Included? If I have two sides where they come together, that's the included angle of those two sides. So the two sets of sides are going to be not congruent, proportional. The angles are going to be congruent. Okay? Good morning. So here's the long-winded version. If an angle of one triangle is congruent to an angle of a second triangle and the lengths of the sides are proportional, then the triangles are similar. So when I put, I can't even put tick marks here. I'd like to show you the sides that I'm talking about. I might put a little highlight on it. Those two sides are proportional. These two sides are proportional. But I can't put tick marks there or else that would mean congruent, wouldn't it? And they're not. I remember us struggling with this back when we were talking about congruence. SAS. It's in that order for a reason. It's two sides and it's the angle between them. All right, because of time, we're going to wrap up with these two problems. Was that enough for you guys to finish copying that up there? All right, explain how to show that the indicated triangles are similar. Well, do you agree if these are going to be similar, then isn't 24, the ratio of 24 to 18, going to have to be the same ratio as 28 to 21? Yes? What is the ratio of S? Is that an R? Yeah. S R to P N. It is 24 to 18. What does that reduce into? Four-thirds. Do you agree? Let's do the ratio of RT to N cubed. That's 28 to 21. 7 goes into 28 4 times. 7 goes into 21 3 times. But that's not enough. That's just SS, right? We don't know anything about the third side, so we can't do SSS here. But look, the angles between them are 90. So these triangles are similar by SAS. Similar by SAS. All right. I need to walk you through the next one, but we're going to run out of time because I do want to pass back your quizzes, okay? Look at this one is tricky. All eyes up here. Look at the order. You would think that this one and that one are kind of just reflected proportional to each other. Do you agree? But be careful. What goes with X, Z in the left triangle goes with YZ in that triangle. So when you go to set up the proportions, it's not 12 to 12, it's 12 to 9. Do you see it? Okay. And then what about 16? It's 16 WZ, XZ. It's 16 to 12. Do you see it? Everybody see it? Okay, so be careful when you set that one up. All right, as you guys write down the assignment, I'll pass out the quizzes. I narrowed it down, so if you, I don't know, if you would have looked at it before this class period, narrow it down, don't block Mrs. Wolf's students' assignments.
It's like a daily paper.
Same. I've got
In third grade, my brother had
okay, that's actually
better word for each.
yeah, we can get for this was I literally okay, so that's trying to for me, yeah. So we talked about it after because we both like, yeah, because I literally just you know what? It's not true. It's okay. I can have I don't know. Oh yeah, we have this one. We have this one.
SAS. Well, but I don't
Get it out.
I just like 2 questions on.
All right, to help you out as you're correcting those quizzes, remember the definition of a parallelogram is that both sets of two sets of sides that are parallel, not congruent. So how do you show parallel? On a graph, the slopes have to be the same. On a proof, like at the bottom of the first page, you have to show that opposite sides are parallel, not congruent. Not congruent.
Wait, I didn't have a calculator. I didn't have a
Yes, it is.